Alright, today is Tuesday, April 5th. I don't know what happened to Alyssa or Lauren, so I have to assume that my worst fears have come true. The Weeping Angels are back. I spend more time than the average person thinking about Weeping Angels, but last week I had a breakthrough while I was learning about quantum mechanics in my physics class. The basic principle behind angels is that when you're not looking at them, they are moving faster than light, or at least at the speed of light. In whatever reason, you cannot see them. But if you're looking at them, they go into a state of quantum lock, which basically means that they turn into stone. Instinctively, whenever something is looking at them, this is both their greatest weakness and their greatest defense. Now, Weeping Angels exist for one purpose: to live off of the potential energy that you leave behind in your own time after they touch you, which sends you to a different point in time to live out the rest of your life. This is one of the more benevolent villains in Doctor Who, but also one of the most frightening, because it plays on those universal human fears of something sneaking up on you and invisible monsters that you can't see, and things that you're looking at being not quite what they appear. Now, how does this relate back to physics? Well, in physics we've been doing atomic and nuclear physics, and last week we were talking about quantum physics. The particular aspect of physics that I'm going to be paying the most attention to in this video is the principle of complementarity. That states that any form of matter can exist as both a particle and a wave. Now, with larger objects like you or me, the wave-like properties are so minuscule as to be irrelevant in day-to-day life. Like, you could calculate the wavelength that I'm emitting right now, but why would you? It's so small that it has no effect on anything. You can't see it, you can't really measure it, it's just too small. But when you get down to smaller particles on the quantum level, which is atomic and subatomic particles, it is very significant. In particular, in the 20th century, scientists were just starting to learn about the quantum world, and they did an experiment with an electron that was rather like Young's double-slit experiment, which proved the wave-like properties of light. In Young's double-slit experiment, he would fire a beam of light at a diffraction grating with two slits in it. The light would separate to go through the two slits and produce an interference pattern on the sheet behind it. This proved that the light was actually producing two different waves when it went through the slits that were interfering with each other. Now, with an electron, scientists have always assumed that electrons are particles. So if you fire an electron at a double-slit diffraction grating, you would assume that the electron would go through one slit or the other, and on the sheet behind it, you would just have one dot. And it would correspond with which slit the electron went through. But that's not what scientists found. They found that when you fire a single electron through a diffraction grating, it actually will produce a similar interference pattern to that of light in Young's double-slit experiment. This was pretty mystifying, as you might imagine, because we have always assumed that. So scientists set up an apparatus close to the diffraction grating that they were shooting the electron through to measure exactly what was happening with the electron as it was going through those slits. This is where it gets really freaky. If you have an apparatus observing where the electron will go, it will still behave like a particle and only go through one of the two slits. So it'll just leave the one mark on the sheet behind it, as if it were always a particle. And that was astounding, because it was entirely observer dependent. If you're not looking, it's a wave. If you're looking, it's a particle. Just like a Weeping Angel. If you're not looking, it can move faster than light. If you're looking, it's stone. And that, I mean, it's just mind-blowing. There's no way that you can really comprehend that, and it's also kind of terrifying. So that is actually how Weeping Angels and electrons, I would like to put forward, are the same thing on different scales. Everyone keep safe. Mina, I hope to see you tomorrow. My advice, don't blink. Don't even blink.